Let's begin the toolpath definition by coming up to Toolpaths and selecting Contour. Select OK. We're working on a 3D part. We hover over here and it says face. We don't want that. We want edge and loop. So the first thing I'm going to do is to select this edge, and it picked the right loop this time. You can see by the blue line moving around here. And so I accept that. And you can see that the arrow, I wish it was easier to see. Maybe that's a little easier to see, but then you lose track of exactly what edge it's on. But you can see that the chain goes in this direction. If you're looking from above, it looks like it's the counterclockwise direction. So our tool will have to be on the right side of that chain. So we'll accept that. It brings up the this window. So the tool we're going to use is one we've created earlier. It's a 1/4 inch flat end mill with length 1 1/4. It's got a diameter of 1/4 inch. It's got 2 flutes. That's what we have, so that's what we have to use. So I'm going to accept that. Cut parameters. We're going to use the 2D type. That's going to come in from the side, so to speak, and do a 2D cut. And so this is the compensation direction, is what I was referring to earlier. So our chain goes counterclockwise from above. So we're going to need to have our tool, I believe, on the right side of that chain. So I'm going to change that to right. And let's see if that works. Depth cuts. Let's make depth cuts at 1/4 inch. Sorry, 1/8 of an inch. That's pretty conservative, I think, but we are using a long, relatively long, thin end mill. So it'll take longer, but I like to go that route. For lead in and lead out, we're going to deselect this completely. Okay. Linking parameters, if you'll recall, is synonymous with Z coordinate information. So the top of our stock is always at 0, 0. Let's go find the depth by clicking. First of all, let's make it an absolute number. 1/4 inch pops up. However, we're going to have the depth be at the bottom of this area here. So that is 7/8 of an inch down. And for our Holman reference, we're going to do one thing in particular. So notice that my Z values are all very small. And that's because our part is going to be elevated quite a bit by our machinist vise. And so I don't want the tool to hit its upper limit stop, or the CNC machine to hit that upper limit stop. So the highest we're going to go coming in and going out is 1 inch above the surface of our part. Okay. Let's see how that looks. Well, it looks like it's on the outside. Let's do a back plot. So there it comes in. Looks like it's taking care of what it needs to. And then you can see how I've got it programmed. So it comes in from here, does its thing, and then goes out that way. Just a little thing that I like to see, because when I see it behaving that way, I know that the orientation I've assumed is correct. Okay, so I think we've got that outside contour. Let's do a verify. Slow it down a little bit. Make it a little bigger, maybe not quite that big, and we'll go through. And you can see that it is taking away that outer edge. It's only 1/8 of an inch in. We have 1/8 of an inch diameter end mill. Now these little posts here, it turns out, don't show up But if you think about the geometry of a rectangle and you're coming around and this thing has to do a circular arc here for reasons, interesting reasons mathematically, so it's going to leave this little sliver in our simulation, but it actually won't be there in the actual device. Okay, I think we're okay in terms of that first contour. We're going to continue with the second contour cut, which is going to define the shoulder and the lip in the next screencast.